Hi everyone. Today we're gonna talk about section 6.1, order of operations and solving linear equations. You will learn in this section that the topic about algebraic concepts, order of operations, and how to solve linear equations. Some very basic concepts. Algebra is a generalized form of arithmetic. So typically, it will involve an expression with variables. So example, x plus 3. That's a algebraic expression. Variable is just unknown. Typically use lowercase letter to represent a variable such as x, y, z. Constant is just a number, right? A specific quantity to 100, so on. So, for example, 3x plus 2, the 2 here is a constant, and x is a variable, and 3 is so-called coefficient. Okay, so we already talked about algebraic expression, involving variables and operation symbols. X plus 2, 3 times 2x minus 3, 2x plus 1, let's see, 3x plus 1 over 2x minus 5, x squared plus 7x, let's see, minus 3. And this is sometimes called a rational expression. So because it's the division of two polynomials, and this of course is a polynomial of degree 2, where its degree is 2 because the power of the variable unknown x is 2, right? And here it's a degree 1 polynomial, and this is also a degree 1 polynomial, and actually this is also a degree 1 polynomial. Terms are just parts separated in general by addition, subtraction. Example here, 4x, 3, 1, 5. Those are terms. Okay. Coefficients typically just means the numerical value or part of a term. For example, here the 4 is coefficient, and negative 3, that's a coefficient. By the way, 4x really means 4 multiplied 2x. Negative 3y always read as negative 3 multiplied 2y. Okay. Like terms. Like term just means that they are terms with the same exponents on the variables. Okay. Example, x squared, 2x squared, those are like terms. 5x squared, like terms, so like terms. Okay. Unlike terms just mean that they are not like terms. So example, x 3x squared, those are unlike terms. Unlike terms. And because you see the exponent 2 here and here, x means x raised to the first power, right? So that's why they are unlike terms. Simplified expression typically means that combine like terms, okay? Quick example would be x squared minus 3x squared, okay? You got like terms x squared. So what you do is combine their coefficients, and x squared again, its coefficient is 1, so 1 minus 3 x squared and equals to negative 2 x squared. And in fact, here you already have applied distributive law. Actually, reversing, okay? Reverse. So let's quickly go over the properties of real numbers, which we need to be familiar with, and which we're gonna use very often. So first one is the distributive property of addition. So a times b plus c, a times the sum, and then you can basically expand it to, or distribute a to each summand in the parentheses. So equal to ab plus ac. That's distributive. And commutative just means that you can change the order of the two numbers and I won't change the value. So a plus b equal to b plus a. So that's the commutative property for addition. Similarly, for multiplication, you also have a commutative property, namely ab equal to ba. And associativity or associative property for addition just means that you can add the first two numbers first and then add it to the third number, or you can elect to add the last two numbers first and then add the result to the first number, and the value, the left-hand side value is equal to the value of the right-hand side. Associativity property for multiplication, similar idea, but applied to multiplication. So let's quickly look at a couple of examples. First of all, let's see 3x plus 6x. How are we gonna combine like terms? Well, 3x plus 6x, what we do is again apply the distributive property in reverse. So basically what we need is combine their coefficients and then multiply to the variable x. And obviously this is equal to 9x. So because the coefficient of first term is 3, coefficient of the second term is 6. So you combine their like terms, combine their coefficients, 3 plus 6, and times x. So you get 3 plus 6 is 9 times x. Okay, so one way to understand combine like terms, you can consider 3x as 3 apple, example 3 apple plus 6 apple. I'm hoping that I'm drawing an apple making sense here. So 3 apple plus 6 apple, obviously everybody knows, then you get 9 apple, right? So that's a way to understand like terms. So you basically like term meaning that they are the same objects. They are the same category of objects. So you can combine them. Okay, 3x plus 6x equal to 9x, something like that. Now let's look at this example, evaluate an expression. What do we mean by this? Well, I don't see any expression here. So let me just make up an example here. Example, let's say we want to evaluate 3x squared plus 2 when x equals to 2. So we want to evaluate. So what we do is just substitute x equal to 2 for x. So in other words, you replace x by 2, okay? So let's see, 3x squared plus 2, right, equals to, when I evaluate it, when x equal to 2, meaning that whenever I see x, I'm going to replace it by 2. By 3x squared, meaning 3 times x squared, so 2. When I see x, I replace it by 2 squared plus 2, right? Now, exponent has higher preference of operation, so I need to calculate it first. So I keep 3 times 2 squared is 4 plus 2. Now, I have multiplication and addition. I need to calculate multiplication first. So 3 times 4 is 12, plus 2 is 14. So that's the answer. Okay. Order operations I already covered a little bit. So first of all, you will need to calculate everything inside parentheses or grouping symbols, such as a pair of bracket, pair of braces. Next, you will calculate exponential operations, right? And then next, you will calculate multiplication and division. By the way, when you need to calculate from left to right. Example here, 3 times 2 divided by, let's say, divided by 2. So what you need is to calculate this expression from left to right when you have multiplication and division, because they have the same preference of operations. So you calculate the expression from left to right. So 3 times 2 is 6 divided by 2, and then you get 3. Okay. And then lastly, you calculate addition and subtraction. Again, you need to do the calculation from left to right. Okay. Let's see, evaluate an expression. Let's calculate this for x equal to 2. So I covered a little bit, but we can do it again. So first of all, I want to make sure we understand a key understanding here. So negative x squared, that's not equal to negative x squared, okay? So the right-hand side is negative x raised to the square, and the left-hand side is you take x squared first, then you take the negative. So if we plug in, say, for example, x equal to 2, then the left-hand side will be negative 2 squared, and the right-hand side will be negative 2 squared, right? Now, negative 2 squared equal to 4, because you got negative 2 times negative 2. The multiplication of two negative numbers become positive. Now here, you need to calculate this, the power first, with 2 raised to the second power is 4. Then you take negative 4. They are not equal. So be careful of this, okay? Because we are doing the algebraic expression. We need to be familiar with the language of mathematics. Okay, that's just the language of mathematics. So x equal 2. So we're going to substitute x equal 2 into the expression. Basically means whenever we see x, we're going to replace it with 2. So negative 2 squared plus 3, 2 plus 10. And notice 3x means 3 times 2. multiplied to 2, okay? So equals to, again, we calculate the exponential first, so 2 to the square, 4, -4 plus 3 times 2 plus 10. So next, we calculate multiplication first because multiplication has higher preference of operations. So 3 times 2, that's 6 plus 10. And then we have only additions left. So we're going to calculate it from left to right. So -4 plus 6 is 2, and then plus 10. And then finally, you sum the two numbers together, you get 12. That's it. Okay, let me stop here.